Welcome to Section 3 of Mastering Unreal Engine Game Development. In this section, we're going to go over how to enable and manipulate the physics system within Unreal Engine, as well as how to perform single and multi-raycasts. In this video, we're going to go over how to add and enable collision meshes to our actors. Also, we're going to enable the default physics settings on our actor. So let's start with creating a new actor, which I'll call my collision actor, and adding a collision object to it. Once the class is created, move over to Visual Studio, where we'll add a property to hold our collision mesh. There are several options to choose from when choosing a basic shape to use as a collision mesh. As mentioned in the lesson Unreal Engine Data Types, the most common are based on uPrimitive component. Those are the uBox component, the uSphere component, and the uCapsule component. For the sake of simplicity, we'll use a sphere to use as our collision. In our mycollisionActor.h file, we're going to add uProperty, edit defaults only, comma, category equal mycollisionActor. Then we're going to add uSphere component, star, to mark as a pointer, collision sphere. With that done, let's move on to initializing the sphere in our CPP file. So in our actors constructor, we're going to call collision sphere equal create default subobject uSphere component text collision sphere. This will initialize the sphere. We'll then set the radius by calling collision sphere set sphere radius 32. We'll then want to make sure that our sphere is visible in game by calling collision sphere be hidden in game equal false, followed by collision sphere set visibility true. We'll then want to enable physics on the sphere by calling collision sphere set simulate physics true. We'll then tell the engine that this is a physics object that we can query using raycasts or the physics engine in general by calling collision sphere set collision enabled eCollision enabled query in physics. Finally, we're going to tell the engine that the sphere should not overlap with any other objects by setting its responses to collision channels. You do this by calling collision sphere set collision response to all channels eCollision response ECR block. And finally, since our actor will only consist of the collision sphere, we're going to set it as the root component of the actor by calling root component equal collision sphere. This is all that's needed for adding a collision sphere and enabling physics on it within the world. So with that, let's move back to the Unreal Editor and compile our project. With the project compiled, we'll create a blueprint out of our new actor to see what the object looks like visually. I'm going to call mine BP_mycollisionActor. When the blueprint is created, it'll be open in the editor and you'll be able to see our collision sphere of radius 32 inside the Viewport tab. You'll also notice that the uProperty macro we specified allows us to modify default values on our collision sphere. So let's change the radius to 64 and make it blue to demonstrate this. Compile the changes and save your blueprint. Then close the window. So let's add an instance of our blueprint that we just created and an instance of our base class to the level and see the effects in Engine. Drag them into your viewport, ensure that they're above the ground, and hit play. You'll see them drop to the ground, collide, and rest in place. At this point, you can use the default pawn that's given to you by Unreal Engine to move the camera and ram into your balls to see that they'll roll around and fall off the level as appropriate, dictated by the physics engine. And there you have it. You have now created a simple sphere that will properly interact with the other physics object in your scene, will roll around, collide with other objects just as expected in any physics engine.